In this lesson, we're going to look at 3 problems in algebra. The first one is one from my childhood. It was the very first question that I asked myself that I could solve with algebra. The second one is from the 1930s, and it's a way to link algebra with geometry that's going to be very appealing to a lot of students. The last one is an unsolved problem of algebra that is nevertheless easy to understand. Okay, the first one. So this is the question that I asked myself whenever I first learned algebra. I asked, are there 3 consecutive numbers that I can add together so that they equal the next 2 consecutive numbers? So that's my formulation. And how do I simplify that? Well, I can take all of the x's on the left side, so that would be 3x and 3x plus 3. So the left-hand side is going to be 3x plus 3. And then the right-hand side is going to be x plus, so it's 2x plus 7. Okay, so I can write that down. 3x plus 3 is equal to 2x plus 7. And then I learned that I needed to group the terms. So I'm going to take the 2x on the right and I'm going to bring it over to the left. And I'm going to bring the 3 on the left and bring it over to the right. Let's see what happens. Okay, so now I get 3x minus 2x is equal to 7 minus 3. And I can solve that. That means that x is equal to 4. What does that mean? Well, that means that the 3 numbers on the right are 4, 5, and 6, and that's equal to 7 plus 8. So 4 plus 5 plus 6, that's 15, and 7 plus 8, that's 15 as well. So this was my first little triumph in algebra, and I still think it's a cute little problem to start on. And you can also ask 4 numbers equal to 4 numbers, and you can solve that in the same type of way. And you can get x is equal to 9, and you can find out that that's your solution. So I had a lot of fun doing this for increasing numbers and finding a nice little pattern there that your students will find as well. The next problem comes from the 1930s, and an unsolved problem in the 1930s was whether you could tile a square with smaller squares of all different sizes. The problem that we're going to tackle is even simpler than that. And it's going to be considerably difficult, but it's going to be fun. And that is, can you tile a rectangle with squares of all different sizes? So I first of all challenge you to get your students to work with this grid paper, which is 33 by 32 squares. So it's nearly a square, but not quite. So it's 33 by 32. And to tell them that you'll give them $5 if they can find a way to tile that big rectangle with a whole bunch of squares, no 2 of which are the same size. They're going to have troubles doing that. Your students will soon come to the realization that this is a daunting challenge. And instead of giving up and going home, you can say, okay, what we're going to do is we're going to solve this geometric problem algebraically. What I can do is I can tile a rectangle with a whole bunch of rectangles. So that's easy, and here's one example of it. Next, I'm going to algebraically assume that all of those rectangles are actually squares. Now, that maybe will take a little bit of time to get used to, but what it means is that if I call that an x, that rectangle an x, it actually means that it's a square and that the sides are x by x. Okay, can you tell me, if I label those x and y, so that y means that that's a y by y square, can you tell me what else you know? Well, one thing that you know is that on the right-hand side we have another square, and that must be of edge length x plus y. Get it? Do you know anything else? Yes, you do. You know both the upper right and the lower right squares. So the lower one is going to be x plus 2y and the upper one 2x plus y. Do you know anything else? Yes, you know now that that one at the bottom is x plus 3y. But now you're kind of stuck. Now you go, I don't know what to do now. But what is that square? Well, this is where your students are first going to get stuck. And a hint is often in order. And the hint that I give is that line there. What is the length of that line? Well, if you look at it from the bottom, you can see that it's x plus 3y plus y. If you look at it from the top, it has to be question mark plus x. But whether you measure that line from the top or the bottom, it's going to be the same length. So we know that we can label that as 4y. So now 4y plus x at the top is equal to x plus 3y plus y at the bottom. Solved. Okay. Knowing that, can we get any more information? Yeah, sure we can. We can get that one on the lower left, x plus 7y. And then we can use that to get our last rectangle, x plus 11y. We still have two variables, and to get rid of those two variables, we have to find another equation. Now, there's several ways to do this. You could, for example, look at the length of the height of this rectangle measured on the left and the height of this whole rectangle measured on the right. But the one that I'm using here is this one, this line here. You can measure that on the left and on the right, that line. On the left, it's equal to x plus 15y. On the right, 3x plus y. Those two must be equal. So I'll set them to be equal to each other. And now I can solve for x and y. 14y is equal to 2x. So that means that 7y is equal to x. Let's choose the simplest possible solution, maybe that y is equal to 1. Then what is x going to be equal to? It's going to be equal to 7. Can we solve using those two bits of information? Sure we can. So let's do that. And there we have the solution. Now it's time to send your students back to the graph paper. Here is an 18 by 18 square in the upper left. We can put a 14 by 14 square and a 15 by 15 square there. Then we can put an 8 by 8 square there, a 9 by 9 square, a 10 by 10, and we can just fill in the rest, and they've got their beautiful solution. I find that this link between algebra and geometry is a powerful way to introduce and inspire many students. You'll find free downloadable worksheets on my website, mathpickle.com. Just go to the grade 10 through 12 section of the website and click on Algebra on Rectangles. The next problem comes from 1879, and it is the brainchild of Andrei Andreevich Markov. The problem is to find integer solutions for x squared plus y squared plus z squared is equal to 3xyz. One solution that your students might find pretty quickly is x comma y comma z is equal to 1 comma 1 comma 1. But there's other solutions that are more difficult to find. How are we going to search for them? Well, let's look at the quadratic equation and the solution to it, which we can get from the quadratic formula. We're going to use that, and we're going to take the solution 1, 2, 5 to find extra solutions. We're going to assume that we don't know what that first term is. We know that 1, 2, 5 is a solution, but let's say that we don't know that. So we're just going to replace that with an x. Okay, so how are we going to find extra solutions? Well, let's put it into the equation. So we have x squared plus y squared plus z squared, but we know that y is equal to 2 and we know z is equal to 5. So that's what we have, and we can simplify that. That's x squared plus 4 plus 25 is equal to 30x. And grouping terms, we have x squared minus 30x plus 29 is equal to 0. That's in the quadratic equation form. Now we can solve for x. X is equal to 30 plus or 30 minus what's in that square root. So let's calculate that, and we get two answers. X is equal to 29 or x is equal to 1. This process may be applied again and again and again to come up with an infinite number of solutions for this Markov problem. Now it's time to play some PlatinuMath games. This is level 1. I have to find a solution to this equation. The first thing I'm going to do is to subtract 8 from each side. Next, I'm going to want to multiply each side by 1/3. And that's going to isolate n. So now I have n is equal to 5, which means I can fire on one of those orbs that has n is equal to 5. And I'm victorious, as expected. Subtract 3 from each side. Uh-oh, that didn't work out well. Now I'm doomed. You know what I can do? I can just fire. Watch this. Okay, so whenever I make a mistake like that, I can just fire and it regenerates my formula. So now I want to subtract 3 from both sides. I hit that. And then I have to divide by 8 or multiply by 1/8. I have isolated n to be equal to 6. Okay, let's fire on that. And victorious again. And last one. Fire. My equation is n is equal to n divided by 24 plus 3. So what am I going to do here? Maybe I'll multiply by 24 first and then figure things out, because I'm lazy. I don't like fractions here. Okay, there we go. 24n is equal to n plus 72, and I'm going to subtract n from both sides just so that all of the n's are on one side. Now I've got 23n is equal to 72. I can multiply by 1 over 23, and I've got the solution. N is equal to 72 divided by 23, and I'm going to shoot. Bam! Good luck!